We've talked about right triangle trigonometry reviewing, okay? And of course, the restriction on that is that it's right triangle trigonometry. We can only use it for right triangles. What happens if we deal with non-right triangles? Well, there's a couple ways that we could go about it. So I'm going to ask you to think about this one. From everything you know about trigonometry right now, this is a non-right triangle. Do you think you can figure out a way to use what you know to find the length of B? What could you do? 10 divided by.
Wait.
Okay.
Because the other dash, do the sine of that, divided by 10, and then you multiply by the sine of 6.
Okay. Okay. No. I know what you're saying. Okay. But I want to say, if you didn't know that, how would you do it? Yes, because clearly you know the sine law. Okay, because you just said it. But if you didn't know it, if you only knew right triangles, what do you think you'd do with this one? If you'd only knew how to work with right triangles. Notice I keep saying that. Yeah. Could I make it into right triangles? Yes, exactly. I could draw an imaginary line here, and I've made two right triangles. So what I could do to find B is, like, let's say this one, we'll do this one outlined in red. Could I find this side using trig? This red side? Yes, because I have enough information in this triangle, right? If I know what this is, do I have enough information now to go find B on this side? Yes. So what I can do is, let's just call this X. We're going to find that, and it's going to help us. So actually, we're going to do trig twice. So how would I find X? What's the trig equation? Sine 65 degrees equals X over 10. And then I multiply both sides by 10. So therefore, 10 times the sine of 65 is going to tell me what X is. Ready to use my calculator? And I'll just tell you, we get 9.1. So that's 9.1. Well, not only is that part of the red right triangle, it's also part of the blue one that I've just traced. How could I use trig again to find B now? Sine 30 degrees equals 9.1, what I just found. Divide B. Multiply both sides by B. And I get B sine 30 equals 9.1. Still don't have B by itself. Divide both sides by sine 30. And I should get 18.2. So it is possible to use right triangle trig to find missing sides and angles in non-right triangles. It's just that we're going to have to do trig more than once. Right? So in this case, we had to do sine twice. And that allows us, and I'm just going to fill this in up top here, a fancy math word for non-right triangles are called oblique. Oblique triangles are non-right. Okay. There is, however, another way. And it actually involves developing a formula that is a combination of what we just did in that previous example. Okay. In any non-right triangle, you've got three angles, you've got three sides, and I've got them labeled like such. These ratios will always equal each other. The little side of A, the length of A, over the sine of its angle opposite. So this over sine A will equal the same value as the length of little b over the sine of its angle opposite, which will equal the length of little c over the sine of its angle opposite. They all equal each other. And you could actually see that on the previous example. If you did If you did 10 divided by the sine of 30, and then if you did 18.2 divided the sine of 65, they're going to equal the same thing. That is called the sine law. Okay? That is the formula for the sine law. Sometimes you'll see the sine law flipped. It'll say sine A over little a equals sine B over little b equals sine C over little c. It's the same thing. It'll still work. Okay? You will always get this formula. You do not have to remember it because it's more important that you know how to use it. Yes. What's that? Sorry? Yes. Yes. That's why we call it the sine law. Only sines involved. Okay? So let's look at that example, or if we looked at that, or no, I'm not going to look at that example. Now, you can use sine law in certain cases with non-right triangles. And I'm not going to go through these right now because how to figure out what method to do when you're working with a non-right triangle, it's actually good to know when to use another law. And then if you can't use that law, then it's going to be sine law. I'll talk about that a little bit later. So I'm not going to worry about this for now. Just know that we're going to use the sine law to answer all the following questions, examples. Okay. So here's what we do. We want to set up an equation, and basically the equation is going to have a fraction on each side with signs on the bottom. What is a side that you know and an angle opposite that side that you know in this 7.2, 63, right? So one of my fractions or ratios is 7.2 over sine 63. The other ratio will be the side that I'm trying to find, C, over the sine of its angle opposite. Well, what's the angle opposite C? No. Opposite C, 71. And according to the sine law, Those are going to equal each other. Now, we've got ourselves a fraction equation again. And this one, well, technically, to get rid of the fractions, we would have to times both sides by sine 63 to get rid of this, and then times both sides by sine 71 to get rid of the other one. There is a quicker way. When you have an equation that has a single fraction on either side, okay, we call this a proportional equation. Instead of timesing by sine 63, then timesing by sine 71, you're going to get the same equation to solve if you cross multiply. This times this will always equal this times this. And why are we doing that? Because we want to get rid of the fractions. Just like we've been doing since grade 9. Every time we see fraction equations, we want to get rid of them. Well, when you have a single fraction on either side, okay, that's a way that you can get rid of the fractions by cross multiplying. And it works in any situation. Like if I said this, you don't have to write this down. How would you find x? 14 times x will equal 8 times 7, 56. 14x will equal 56, x will equal 4. Okay, so we can solve it by cross multiplying. Okay, so after we cross multiply, the equation looks like this. Actually, I'll put the C one first. It doesn't matter which one you put first. I'm going to put the one with the variable first. So you get C times sine 63 equals sine 7.2 times sine 71 degrees. I still don't have C by itself. What's the last thing I got to do to get C by itself? Divide by sine 63, both sides. So therefore, C is going to be this. So on your calculator, and if you've got one with you now, you should try it, just to make sure you know how to do it, because we're doing multiple operations now with trig. 7.2 times, I just do 7.2 times the sine of 71, and then I put equals, and then I divide sine 63. For the answer? No, I said I do this times this, then equals, and then I divide this, and then equals again. You should get 7.6. Oh, I'm in degrees. No, you should get 7.6. That's right. You should get. Okay, good. Okay. How about this one? Yep. 100 degrees is opposite the B, so I would go B times sine 100. That's one of my fractions. The other fraction must involve 5, right? What's the angle opposite 5? It's not 35 degrees. It's this one, isn't it? I don't know it. I'm not given it, but I can figure it out because I know these two. It's 180 minus 100 minus 35, or 180 minus 100 plus 35. So I have to figure this angle out first before I can use sine law. Now what does the other fraction look like? 5 over sine 45. And now I make them equal to each other, cross multiply, and then divide to get the variable by itself. So I get b times the sine of 45 degrees is equal to 5 times the sine of 100 degrees. Divide both sides by sine 45 to get b by itself. So b is going to be 5 times the sine of 100, and then I'm going to take that answer and divide sine 45. And I'm going to round to the nearest whole number, because that's what we're asked to do. 7? Good. There is one other situation with sine law. What happens if an angle is missing? We just did 2 examples where a side was missing. What about this example? Well, give me one of the fractions I'm going to use in my formula. 14 over sine 39. And the other one I'm going to use, 21 over sine x. They equal each other. I still cross multiply to get rid of the fractions on each side. And I get 14 times the sine of x is equal to 21 times the sine of 39 degrees. Now what? What do you think? Divide both sides by 14. So we get sine x is equal to 21 times the sine of 39 degrees divided by 14. What's that? Like, calculate this? Sure. Yeah, so to get x by itself, don't we have to do the sine inverse? Yes. So this one is a little bit more of a complicated operation. You've got to do the sine inverse of these 2 operations. So there's a couple ways that you could do it. Some students, what they will do is they will calculate this, they'll get a number, they'll write that number down, like if they'll do 21 times the sine of 39 divided by 14, and then they'll write down 0.94398, and then they'll put sine inverse of that. Okay, if you've got the calculator to do it, like I found this, and it's on my display, and then I can just do second sine inverse of the previous answer I just got. And that's going to give me 70.73. Okay? Or you could have done the whole thing in one long calculation, but you got to be careful of using parentheses correctly. Yes, Rita.
When we get that really low number for the first time, do we have to write the whole number?
No, I would say, you know what, 3 decimal places. Yeah. What's that? For the final answer? 71 degrees, rounded. 71 degrees. Okay. Just give me a second. So this next page, before we do the final example, this is just a proof of where the formula comes from. Okay? Basically, what we're doing is we're doing sine twice and putting it together. Like we're doing right triangle trigonometry sine twice, putting it together in a formula. That's as far as I'm going to explain it. Because like I said, the most important thing is, do you know how to use it? All right, this one we're going to have to draw before we figure it out. So we've got 2 points, X and Y are separated by a river. So there's our river. Here's X. And we have no idea if they're directly across from each other or if they're at an angle to each other, so I'm not going to put them directly across. So that's the first sentence. And Chelsea's standing here. So she wants to know what's the distance without having to take a tape measure, jump in the river, and swim across to measure, which is not very efficient. So she's going to use trig. So what she's going to do is she's going to walk to another point along her side of the river and call it Z. And that distance that she walked was 150 meters. And you see the triangle that's being created. Like so. What she also did is she's got an instrument that she can measure these 2 angles from where she's standing to Y opposite the river. So she measures ZXY. Which one is ZXY? What you do, look at the middle there. That's where the angle is. So ZXY is this angle at X. So that's 45 degrees. XZY, that's the angle at Z, this one. And that's 60 degrees. She now has enough information to do trig, to figure out, remember, and let's just, actually I'm going to call it D. I'm going to call it X, Y, or Z. Remember, she wants to find the distance from X to Y. So on her side, she was able to find 3 measurements, 2 angles and a distance. And that's enough, along with some trig, to figure out how to find D. So what do we do? Yeah, we need to find the angle first. Because remember, this angle here goes with this side, doesn't it? Well, I got to find this by doing 180 minus 45 minus 60. And I get 75 degrees. Now I'm ready to set up my sine law. What's one of my fractions? So what I'm trying to find over the sine of its angle opposite, which is 60, so d over sine 60, yes. That's going to equal what? 150 divided by sine 75 degrees. Yes.
Why did you decided to do 150 divided by sine 75 first? Would that be wrong?
No, I know what you're doing. And that's fine. That's basically what cross cross multiplying is. You're just doing it in a slightly different order, but that's fine. So we cross multiply. We get d times the sine of 75 degrees equals 150 times the sine of 60 degrees. Get d by itself by dividing both sides by sine 75 degrees. And d is going to be approximately, and we are asked 1 decimal place. Anybody get it? Mm-hmm. Come on. 134.5 meters. Good. Okay, so that's the sine law. There are some situations, however, when the information we're given, we can't use sine law. We can't make an equation to solve for one thing. We need another law to help us in those situations, which we'll talk about next week. So for Wednesday, which is the next time I see you, that will be exercise 4.1 and exercise 4.2, numbers 1 to 4. Just do the sine law questions in exercise 4.2.